Projectiles, Inclined Plane, Type 4 Landing Angles. So in 2010, we had a particle projected up a plane, and this time we were given the initial speed as 80 meters per second. We were told the line of projection makes an angle of 30 degrees with the inclined plane, so not the horizontal this time, so the inclined plane, and the angle is inclined at an angle of theta to the horizontal. This time we're also told that the particle strikes the plane at an angle of tan inverse of 2 over root 3. In other words, this is the landing angle. Now we're asked to find the value of theta here and then the speed at which the particle strikes the plane. So value means we want a decimal answer, and speed then is going to represent the magnitude. Okay, so be careful with that. It's not the velocity we're looking for, it's the speed, which means we need the magnitude, which means we need Vx and Vy on landing. So let's draw a diagram to represent what's happening here. And we have theta, we have our initial velocity, and this time it's 80 meters per second. We're given the angle of projection with respect to the inclined plane is 30 degrees. And then on landing, this will be our velocity. And we're given the landing angle, L. And of course, if I was to resolve that landing angle, always using broken dotted lines or a different colour, we can see that our velocity in the x direction and the y direction versus if I go to the initial velocity here in the y direction and the initial velocity in the x direction. Well, the initial velocity in the x direction and the final velocity in the x direction are in the same direction, so therefore they're both positive. Whereas we can see the velocity in the y direction is actually in the opposite direction to the initial velocity, which means we will give it a negative sign then as a result. So something to be mindful of. So we're told that L is equal to tan inverse of 2 over root 3, which basically means that tan of the landing angle is equal to 2 over root 3. Now we also know that tan of the landing angle as a formula is actually minus Vy over Vx, because if I look at my diagram, well, the opposite is Vy and the adjacent is Vx. So in other words, tan theta is opposite over adjacent, so minus Vy over Vx. So we also know on landing then that Sy will be equal to 0 as well. So both Sy equals 0 and tan of our landing angle will come in useful here when we're trying to find the value of theta. So the second thing I'm going to just write down before we start is the fact that this is our alpha and our beta normally, okay? So therefore alpha is equal to 30 degrees. So if I get cos alpha, well, cos 30 is equal to root 3 over 2. And sine alpha is sine 30, which is a half. So that'll come in useful then when we're doing our table out. And of course, U is 80 meters per second. So you're going to pause the video and do U, A, B, S, and T in the X and in the Y direction. And don't forget, this is the inclined plane, so we have to resolve our gravity. Okay, so if we have U cos alpha, U being 80 and cos alpha being root 3 over 2, then we get 80 times root 3 over 2 gives us 40 root 3 for U in the X direction. And we have 80 times sine 30 gives us 80 times a half, which is 40 in the Y direction. We have minus G sine theta in the X direction and minus G cos theta in the Y direction. V equals U plus AT in the X direction will be 40 root 3 minus G sine theta t. And V in the Y direction then will be 40 minus G cos theta t. S in the X direction will be UT minus a half AT squared. plus a half a t squared. So that gives me 40 root 3t minus a half g sine theta t squared. And in the y direction, 40t minus a half g cos theta t squared. And t will be 10. Okay, so to get the value of theta, we're going to look at trying to find our time of flight. So we know that on landing, sy will equal 0. And therefore, if we take our equation for sy, we have 40t minus a half g cos theta t squared. And we're going to let that equal to 0 and then solve for t. So I'm going to multiply everything across by 2 there to get rid of my fraction. And then take out highest common factor, which is t, leaving me with 80 minus g cos theta t. And both multiply to give me 0, which means one or both must be equal to 0. And therefore that allows me to get t is equal to 80 over g cos theta. So in other words, sy is equal to 0 at the start because it's on the plane, and at the end because it lands on the plane. So in other words, this is my time of flight. Now, normally we could take the second equation, which is tan of the landing angle, and we could work out time of flight as well and then equate them. But because I'm looking for my magnitude in the second part of the question, I know I need Vy and Vx anyway. So what I'm actually going to do is I'm going to say, well, on landing, I know that L is equal to tan inverse of 2 over root 3. In other words, tan L is equal to 2 over root 3, and tan L is equal to minus Vy over Vx. So rather than subbing straight into my formula for tan L equals minus Vy over Vx, I'm actually going to work out Vy and Vx separately because I'm going to need them in part 2 later. So we can say Vy is equal to 40 minus g cos theta t. And we've just worked out our time of flight, where we saw that the time of flight was 80 over g cos theta. So g cos theta cancels there. So that's nice and handy because we get 40 minus 80, and therefore Vy is equal to minus 40. And we were given units in this question, so we should write in units here. And you can see again, if we go back to our diagram, that the Vy, we expect it to be negative because it's in the opposite direction to Uy. And therefore, we can see that's why we're getting minus 40 here for Vy. So we're now going to do the same for Vx. So Vx, we said, was 40 root 3 minus g sine theta t. So if I sub in my time of flight, well, my time of flight was 80 over g cos theta. And of course, g cancels, but we're left with sine theta over cos theta this time. And sine theta over cos theta we know is tan theta. So that leaves me with 40 root 3 minus 80 tan theta. Okay, so we now have to find out what is theta. And when we find out theta, we can come back to this equation at a later stage for Vx and sub back in to work out what Vx is. So what do we know? Well, we know that tan L is equal to 2 over root 3, and that tan L is equal to minus Vy over Vx. So we can now say that 2 over the square root of 3 is equal to minus Vy over Vx. And then if I cross multiply there, I'm going to get 2 times 40 root 3 minus 80 tan theta. So that gives me 80 root 3 minus 160 tan theta. and that equals then minus 40, which is just plus 40 times root 3. And if I rearrange to get tan theta on its own, and multiply both sides across by minus 1, well then I get tan theta is equal to 40 root 3 over 160, which of course simplifies down to root 3 over 4. Now I'm asked for the value of theta, so therefore I have to find my decimal answer, which is 23.41 degrees. Okay, so I can't leave it as tan inverse root 3 over 4, and I'm not asked for tan of the angle, I'm asked for theta, and I'm asked for the value of theta. So now I know what theta is, I can actually go and find out what Vx is. So the second part of the question is to find the magnitude, in other words, the speed on landing. Okay, so in order to do that, I need the square root of Vx squared plus Vy squared. Because again, if I go back to my original diagram, I have the magnitude is the hypotenuse in my triangle. So it's h squared is equal to o squared plus a squared. So h is equal to the square root of o squared plus a squared. But of course I have to work out v of x first of all. And we have v of x is 40 root 3 minus 80 tan theta. But of course we worked out tan theta there to be root 3 over 4. So 4 goes into 80 20 times, and we're left with 40 root 3 minus 20 root 3, which is of course 20 root 3 meters per second. So now we have our two velocities, then we can get the magnitude of our velocity, in other words our speed, is equal to the square root of 20 root 3 squared plus minus 40 squared, which then gives me the square root of 2,800, which is 20 root 7 meters per second. Sorry, 20 root 7. I didn't realise I hadn't pressed pause there. Okay, so we looked for the magnitude, or as in decimal form, it could be 52.92 meters per second. Okay, so let's look at the breakdown of the marks then. So if I go back to the start, we have to find the value of theta. So in order to find the value of theta, we had to work out the time of flight. So we got 5 marks for that. We had to get Vy and we had to get Vx. So we got 5 marks for each of those, Vy and Vx. We also then had to work out what theta was, which gave us another 5 marks. And then we had to work out our magnitude. So for both getting Vy and Vx, we were getting 5 marks for the two of those together. Now we'd already gotten 5 marks previously anyway for minus 40. But for writing both of those down combined together, you were getting 5, in other words, subbing it into the formula, and then 5 for getting the answer. So in total, this was a 30-mark question. Okay.